Hey guys, Mr. Gran here, continuing 3.5 symmetry. In this video, we'll talk about rotational symmetry. All right, so what is rotational symmetry? It's when you can spin something and it comes back to the same orientation and doesn't change. The way we can figure out our rotational symmetry, we list it based on the degree of the rotation that it takes to achieve symmetry. So the way we can do that, we can find the number of lines of symmetry, is what that should say. We can divide 360 degrees, that's a full circle, right? We can, a full rotation, we can divide that by the number of lines of symmetry, and that gives us the rotational symmetry. One way we can kind of check our work is we can list out the degrees until we get to 360. So like, let's say that we had 120 degree rotational symmetry, meaning if I take a shape and I rotate it 120 degrees, it maps onto itself. Well, I would do 120 degrees. If I do another 120 degrees, that would be at 240. Another 120 degrees would be at 360. So in this case, there would be 3 lines of symmetry because 360 divided by 3 is 120. Okay. Point symmetry. Point symmetry is when a figure has 180 degree rotational symmetry. It's just sort of a special kind of symmetry, a really common one where if you flip it 180 degrees, right, so you flip it kind of upside down, it maps back onto itself. All right, so looking at this, determine whether or not this has rotational symmetry, and then if so, what the degrees are, and determining whether or not it has point symmetry. Well, one way I can do this, I can think about the lines of symmetry. This shape has 2 lines of reflectional symmetry, right? I can split it evenly in half, or the 2 halves are identical in 2 directions, right? So that means that its rotational symmetry is 180 degrees, because if I do 360 divided by 2, I get 180. Because it has 180 degree rotational symmetry, this has point symmetry. Now I can also kind of visually check this, right? If I look at it and I think about it, if I flip this 180 degrees, it maps back onto itself. So this kind of checks out. All right, our star here. How many degrees is this one's rotational symmetry? Well, I know I've got a line of symmetry here. I've got a line of symmetry here, so that's 2. I can also go corner to corner like this for 3 and 4. So this is going to have 90 degree rotational symmetry. I can do 360 divided by 4, and that equals 90 degrees. So this one is a no to, it is symmetric, it has rotational symmetry, but it's a no to the point symmetry. Now, so that 90 degree symmetry, what that means, if I take this and I just rotate it a quarter of a turn, it's going to be like back onto itself. Like if this arrow, this top arrow rotates 90 degrees, now it's over here, the whole shape will look the exact same. All right, a couple more. Looking at this one, this does not have rotational symmetry, and here is why, right? It does have reflectional symmetry, but there's only 1 line of symmetry, meaning that 360 divided by 1, that's 360 degrees. That does not count. It doesn't count for symmetry if you rotate 360 degrees, because everything has 360 degree rotational symmetry. All right, and our last one, 5-pointed star. Let's count up the number of lines of symmetry and figure out what its symmetry is in degrees. So we've got 1. If I go through the points, 2, 3, 4, and 5. So there's 5 of these. So I can do 360 degrees divided by 5. And 360 degrees divided by 5, that is 72 degrees. So no point symmetry for that one, but it does have rotational symmetry.